particularly pleased to hear you say that there's going to be no deep sky notes tonight, so that gives me an extra 15 minutes to watch it. I did this talk a couple of weeks back, and they probably fell ill like a lot of people have done, and came back to it this morning and thought, I better have a quick run through it, see how long it takes. And it was about 3 hours. So I've done quite a bit of butchery on it, and I may have to leap over a lot of stuff. But I'm going to make a few assumptions, which is people have got something like a digital SLR camera and that they have taken some long time exposure pictures. What I plan to do then is show how we can stack and calibrate those pictures in a piece of software called Deep Sky Stacker. Then, while that's working in the background, jump back into the talk and give you some idea what stacking and calibrating means and why we do it. So a bit of theory and some chat on cameras and files, types and bit depths and that kind of stuff. Hopefully not too much. Stop yawning. And then at the end, when that little talk's run through, I'm hoping there's going to be time for me to take the picture that I've just calibrated and stacked, put it into Photoshop and develop it so that we end up with a final picture. So it's maybe a bit ambitious, but that's what I want to try anyway. First of all, disclaimer, thank you. I am standing on the shoulders of giants. None of this is anything I've made up myself. It's stuff I've picked up as he drops his telescope. It's stuff I've picked up over the years. Want to show you what I do, but I'm always conscious that there are people who know more about things than I do, so if I make any obvious bloopers, please let me know, and we'll try and correct them, because everybody's here to learn. But if you've got any actually out-and-out questions to do, if we can maybe save them to the end, otherwise I'll just never get through everything. Okay. There are two basic types of D-sky imaging. Wide field stuff that you do off a fixed tripod with your digital SLR, looking to make star trails or catch comets and what have you with a camera lens. I'm not really going to talk about that, but a lot of the techniques that you can use apply to the stuff I am talking about, which is the deep space objects, looking for nebulas and star clusters and galaxies and what have you, using long exposures. It says a sensitive camera. A digital SLR, generally speaking, is more than sensitive enough for the job. Maybe do some modifications to it, and I'll chat about those a little bit. A decent telescope, almost any telescope you buy these days from a proper astronomical supplier is a decent telescope and will work. So if you've got one, you can probably use it for this purpose.
You mean telescope going out of business?
Not quite. They now call themselves Bresser and sell stuff through Lidl's and Aldi. But the telescopes they do make, you can use as guide scopes, but you wouldn't want to image through them. The main point is an equatorial mount. Probably the most important part of deep sky photography is the mount, not the telescope and the camera, and the way you guide with it. But the basic process is capture the images and the calibration files. I'm going to assume you've caught the images, and I'm going to explain what the calibration files are. But then you're going to use software to calibrate and stack the images to produce an intermediate file. It's not a final image by any means, but you've done most of the work you need to do to it. And then you're going to import it into something like Photoshop or the GIMP, which is a free version of Photoshop you can get, or any one of a number of photo processing softwares. I'm going to use a very early version of Photoshop, which you can get for free a bit later on, and process it up into a final image. And as I said, save time, we'll concentrate on stages 2 and 3 here. So what I'm going to do now is just jump out of this, end show, there we go, minimise that, and open up a piece of software called Deep Sky Stacker, if I can find it. There it is, there you go. Right, so I'm not casting a shadow on the screen. This is a piece of free software you can download. I'm amazed at the quality of the free software you can get for anything to do with astronomy, and astrophotography is no different. I just want to run through this, load some files into it and get it going, and then go back to sort of the theory presentation. There's lots and lots and lots to it. You can experiment with it all you like and never find all of it. I just want to point out some of the things that I do, which will maybe help people. So the first thing is to load files into it. So I'm going to open some picture files, and I've already got it set up here for some pictures of the Seven Sisters, M45, so I'm going to open those up, and as you can see they appear at the bottom there as a load of files, and I am going to check all, which means I'm going to select them all, and you see the little ticks appear down the side there. So they're all available for stacking, and you can look at any individual one. It takes a second to convert it to a format that can be displayed, and there it is. Not very impressive, is it? That's I think that's a 4-minute file, a 4-minute capture file. Okay, so this little jobby up on the right-hand side changes the visualization, so you can see if there's actually anything in it. It doesn't change the file. It does nothing to it. So if you drag that across there, it brightens it up a bit, and suddenly you can see there's some stars in there. Yeah. So you know you've actually caught something, so we can go and work on that. Of course, if you go to any one of these files and go through it and have a look at it, you can look at the individual stars like this by moving the cursor over individual ones, and you can say, oh, it's quite a nice round star, so the guiding was working pretty well. If you find one where they're elongated, you want to discard it. So all you do, for instance, is discard it, is just when it stops, there you go, just there, get rid of it. I'm not going to use that one, alright? And you can make any one of them, I'm just choosing one at random, the master file, which is the one that all the others will be aligned to, just by double clicking on it, nothing else. Yeah? So that is the one that all the others are going to be aligned to. Now we're going to want to add some calibration files, and as I said, I'll explain what they are, physically what they are, but they're there to try and get rid of various elements of noise in the picture that you don't want. So I'm going to open some dark files. These are exposures which are taken at the same length as the light picture, but with a cap on the telescope. So what you're photographing is noise in your system. Right. Okay? So that's your dark files. Well, I've got 20 there. I would suggest a minimum of 10.
Right.
Because you're going to average them out, because the noise is not consistent in each and every file.
No.
It gets averaged across all of them. So if you take a decent number of dark files, you can average the noise out. It's the same with the lights, the actual picture files. You want to take a decent number to average out the noise.
And those are all 4 minutes?
Yeah. There's other kinds of calibration files there, flat files. I'll explain those later. You can add them if you want. I'm not going to bother. Dark flat files and offset bias files. The more expert you get into this, you'll find people arguing in the internet all week long about, yes you do, no you don't, no you have to have them. Generally speaking, the only ones you'll have to use are dark files, and if your system has something called vignetting in it, or if you've got a lot of dust on your sensor and what have you, flat files are a great help. I'm just going to use the picture files and the darks. Now what we want to do is register all the stars one on top of each other. So register check pictures. Okay, this opens a little box. You can just leave the defaults, but under advanced you've got a slider. This catches people out on this software. Star detection threshold. You'd assume if you wound the detection threshold up, it would detect more stars. It doesn't. It works in the opposite sense.
Oh, right.
It works in the opposite sense. The default is 15. I usually wind it down to 10 because I found at 15 sometimes I'd have like 20 light files and it would say it's stacking 7 or 11 or something. That's because for some reason it hasn't quite found all the stars in the other ones. So if you push that over to the left a little bit, it usually finds all of the stars. Alright? I'm just going to cancel that because I don't want it to start working yet. The other thing that's interesting down here is RAW or FITS digital development settings. RAW files are what you should get off your Canon camera, yeah, or your Nikon camera or what have you. You don't want to use JPEGs or other formats, you want to use RAW because it uses as much of the basic data that the chip actually detects as possible. FITS files is what we usually get from a dedicated deep sky camera, file instrument transfer system, I think. something like that, yeah. An internationally recognised, scientifically valid file format. If you can use FITS, fine. If you've got a digital SLR, use RAW. There can be problems with that, I'll mention it later. Something Ken was talking about earlier, quite often you end up with funny colour balances. You can boost the amount of red by changing this with reference to green, or you can boost the amount of blue with reference to green. Assumes that green is a standard in the middle, so you can boost them up or down if you want to, and that's just some processing the kit does, or the overall brightness even. Now this thing down here, Bayer matrix transformation, bit of a mouthful. Colour cameras aren't colour cameras, as I'll explain, they're actually monochrome cameras with filters built on in front of the sensor. And they have to be red, not colour red, as in red out, in a direct specific sequence, red, green, green, blue, or what have you. And then that's all done mathematically to say that block of 4 is a certain colour. The fast way of doing it is called bilinear interpolation, and it'll rip through, but it'll produce a fairly muddy picture. It's a cheap and dirty method of de-Bayering the colour data. The best is this, adaptive homogeneity directed interpolation. That is a mouthful. The other ones I've never used. Bayer Drizzle does produce a slightly higher resolution picture, but will take all week to work out. And the one down here is sometimes useful if you've tried using a narrow band filter, maybe a hydrogen alpha filter at the deep red end, which does work. It just doesn't collect very much light in a digital SLR, but you can do it. In which case you want to ignore all the other colour filters, so you can use that process, superpixel process. It halves the overall file size because it lumps all the pixels together into one. Yeah, but that works. FITS over here is a useful setting, because I talked about the Bayer matrix and how you can decode it. Well, this is set up for a generic red, green, green, blue, but if you look down here, you've got a lot of cameras. So if you've got your EOS 5D or something, 1D, 5D Mark II, and select it, it looks at de-Bayering specifically for that camera. So if it's in the list, even though it's not FITS files, it's a RAW file, you may as well use it. Yeah? So I tell you, this software is not what you'd call necessarily easy to use.
No, I find it.
But everything's there, so I'm just pointing out a few things.
Quick question now. Cameras can do de-Bayering for you.
Yes.
When you capture RAW, are they never de-Bayered at that?
Well, when you look at the captured image on the screen, if you're capturing it into a laptop, or if in fact on the back of the camera, it'll still be in colour, because it is de-Bayering, but it's de-Bayering post-capture. If you capture it in a TIFF file or a JPEG file, it'll de-Bayer it and save it in that de-Bayered format. Whereas if you capture it in RAW,
it will not be de-Bayered.
It will not be de-Bayered. It might de-Bayer when you look at it, but the filed format won't be.
Okay.
And it's better to do that in software, something like this, because it uses a better algorithm to do it. Okay, so we'll just cancel that. So, wanting to go on with the stacking process, one of the really good things about this, stack check pictures, is down at the bottom, recommended settings. Because the software looks at the number of pictures you've got and the kind of pictures you've got and makes recommendations for you to change. Yeah? So it's already suggesting we use that AHD de-Bayering. Good. It thinks you should reset the white balance settings. I like to play with the white balance settings in Photoshop afterwards, but that's a default setting. I'll leave it. I'm not going narrowband, so I'm not going to change to superpixel mode. Per channel background calibration, I'll look at that a little bit in a minute somewhere else. The stacking mode, when you're putting the pictures one on top of the other, what are you going to do? Take an average, take a median. If you've got enough of them, it recommends either this sigma clipping combination or auto-adaptive weighted averages. If it's recommending it, I'm going to use it. Yeah? And the master dark, well, I've got 20 dark frames, so it's also using that recommendation. So that's what I'm going to do. I'll just click OK on that and go back to the stacking parameters. And you can see we've got the light frames, the dark frames, how it aligns them, what it does with intermediate files, a little bit of cosmetic work to clean up the picture, and what the output is. This is all straightforward for the result. Do I want the standard mode, which is with reference to that frame I've double clicked on? Do I want a mosaic? Do I want the intersection? Or do I want to draw a custom rectangle? Well, all my pictures are pretty close to being aligned anyway, one on the other, standard mode. The light frames themselves, this is where I changed the per channel background calibration. I don't like there to be any. Yeah, so I go down to options and I go none. That means the red, green and blue, rather like in the histogram diagram, aren't actually aligned with each other. That's because I'll muck about with that in Photoshop afterwards. Okay? The dark frames, I'll just leave it to it. It knows what it's doing. Alignment, I like to use automatic. If it doesn't work, it says it can't align some stars, then I'll muck around with that slider I showed earlier, or I'll try one of the other modes, but usually it works on automatic. Intermediate files, TIFF files is a lossless format, there's no compression applied to them, so I'll let it work in TIFF or FITS files. I like TIFF because I like TIFF as the output file that I'm going to use in Photoshop later. Okay, cosmetics, detect and clean hot pixels and cold pixels. Hot pixels, the sensor on the camera, you show the weakest possible light to it, and some of the pixels are going to show full brightness immediately. They're hot pixels. And some of them you can shine a laser beam on them and they'll still be black. They're dead. Those are cold pixels. So the default settings are like this. 2 pixels wide, 50% detection threshold. I won't pretend to know what they mean, so I just leave them alone, and the software seems to find them and get rid of them for you. Okay, and the output, well, I'm going to create an output file. If I don't tick that box, it's a bit of a waste of time. I'm going to call it autosave, and if I run the software 3 or 4 times, I don't need to change that because it'll just add autosave 1, autosave 2, etc. So, and I can pick the one I want. And it creates the output file in the folder of the reference frame, so I know where it's going to be, or you can put it in anywhere else you like. Yeah? So, there you go. Going to start it running. Okay. And it's starting to add together all the dark frames, and then it'll do the light frames, it'll calibrate them, and it'll come up with a final image. Good. So while that's working, I can go back to this in the background. So, here we go, slideshow, start from current slide, there we go, right. This is not what you want to do if you want deep sky work, afocal setup. What you want to do for deep sky work is prime focus. So there you've got yourself a digital SLR, prime focus on a Newtonian. This happens to be a dedicated camera, prime focus of a refractor. That's what you're going to want to do. So you're going to need some method of attaching them. There are all sorts of adapters out there for any different camera or telescope you can think of. T-threads and screws and bayonet fits, or in this case that fits into the eyepiece holder directly and you clamp it in. The best attachment is something that screws together because it's the most rigid. But all sorts of different ways of doing it. Most of the dedicated CCD cameras actually have something called a T-thread in there, 42mm T-thread. And as I say, you can get adapters for everything. There's a DSLR just plugged into the eyepiece holder, and that is your dedicated camera screwed in. The thing to notice for this is it's a one-shot colour camera, so there's no filter wheel, and there's a second telescope there, and plugged into the star diagonal is a little tiny webcam type camera. It's a planetary imaging capture camera. And almost all of those have an output, RS12 output cable on the back, which will plug into almost every mount, and that is your guiding camera. So that telescope there is looking at a star somewhere close to the object you're imaging, and the software in your laptop is looking at that star from the guiding camera, and if it starts to move, it says, "Oi mate, go back, put it back where it is." And in the process of doing that, all of the stars that's in your imaging camera will stay as close to still as possible, and you'll end up with nice, tight, round stars over as long as you like. Auto-guiding, that's what you really need. Okay, just to show, a mono camera has to have a filter wheel in there, because a mono camera, obviously, you've got to combine different colour filters to get a shot. I'm not going to really concentrate on those at all. There's the other one or two slide. That's a dedicated SB camera. It's got an integrated filter wheel in there that you can just change off your laptop. But if you want to pay 4,000 quid for a camera, be my guest. Okay, we're looking at dim targets, so we want long time exposures. Digital SLRs straight off the shelf, you're probably limited to something like about 4 minutes, because you get thermal noise in the camera, which is heat. The sensor sees heat as a form of light and captures it, builds it up in your picture, so you get the sort of grey mist slowly whitening up as you take your pictures over longer and longer times. Yeah, you can't do too much about that, but if you limit the time exposure to say 4 minutes maximum, you can get rid of a fair amount of that noise using the dark frames and the flat frames and things, the calibration files. You can't really get rid of it if it builds up above the noise builds up above the signal level. So if it gets brighter than the nebula that you're looking at, it's lost forever. So you have to limit the time. If you've got a dedicated camera, obviously it's usually cooled, which gets rid of one of the noise sources, and you can then take as long as you like. I usually image around 10 minutes, unless it's a very bright object. Pleiades is fairly bright, so for 4 minutes or something. If I want to go for a faint nebula, I may be doing 20-minute exposures, all of which are obviously auto-guided. Places severe demands on the telescope mount to avoid tracking errors. As I said, the mount's probably the most important thing of the lot. Equatorials are best. You can do it with an Altaz mount, but you get field rotation at the edges of the image. So again, you're limiting the length of time you can expose for. You can process it out, but it's substantially more involved, and I don't really want to go into it. Equatorial mounts are the way ahead for long time exposures. You can get great images with relatively inexpensive gear though. You don't have to spend a fortune. Things to consider. Okay, off-axis guide or parallel guide scope and guide camera. This is what I mean by a parallel guide scope. Okay, this bar is gripped in my telescope mount. This is where my imaging camera goes. This cost me 55 quid from Lidl's, and that included the tripod and eyepieces and all the stuff that I threw away. All I was interested in is this. I use this as a guide scope with a little webcam in there, or a planetary imaging camera in there. My imaging camera goes on this side. Off-axis guiding is another way of doing it, which reduces the mass on the mount and can be very useful. Little jobby like this. One end attaches to the back of the telescope, the other end attaches to the camera. And in there, I don't know if you can see, there's a little piece of glass. It's a prism. Bounces light up here. You put your guide scope in the top. So you actually, your guide camera, I beg your pardon, in the top. So you're actually using the one telescope to both guide and image. So that can be very useful, and it reduces the mass as well. The one problem with these, as Ken pointed out earlier, is the little tiny prism in there. You can spend half the night trying to find a guide star. But once you've found one, they are very useful. Press Here Dummy, PhD. Outstanding piece of guiding software, completely free. An American company called Stark Industries, who I always thought made Iron Man. But in fact, they make software for astronomy, and you can download it for free. And it's, as the name suggests, it's very easy to use. Your telescope and camera specs, there's a lot spoken about this. Oh, I'm going to match this to that, and I'm oversampling the sky or undersampling the sky. Rubbish. People have got what they've got. They've got the camera they've got the telescope they've got. Use it, you'll get the results you get. If you get really advanced, you will start wittering about that, but it's not really important. Image capture techniques, pertinent issues. Well, the main one of those is focus, 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 focus. There's no point in getting a whole night's worth of images just to find that they're fuzzy little snowball stars instead of pinpricks. This thing, batten off mask for about 12 quid off the internet. That one can be adjusted, you know, for small telescopes or big telescopes. Just slide the pins out. Goes over the front of the telescope. How to use them on the internet, dead easy, won't go into it now, but they are brilliant for getting perfect sharpness. Much better than the tools that come with some of the capture cameras, which look at full width, half maximum, blah blah blah. Batten off mask, brilliant. Fakeness and feasibility, there's no point having a short focal length telescope with a digital SLR which has got fairly small pixels and try and image a tiny planetary nebula. Don't bother. There's a piece of software I'll show you later which gives you some idea what your field of view is going to be, which is very useful, and that's free too. Calibration techniques, yes, we're going to talk about that. That's the different frames. Dark frames, flat frames and what have you. Processing the image is what I'm going to do at the best to show you some processing techniques. I'm going to show you at the end. The mount, okay, mount is essential. Good tripod, don't want something floppy. Some people drill holes in the metal legs and fill them full of sand. Best mount of all is one that's on a steel pier. But wooden tripods are well regarded for this sort of thing. You just want something that doesn't flex as all that mass is moving around on the head of it. Well, the weight on the mount should be half the rated capacity. Yeah, they love to say this can carry 22 kilograms of weight. Don't forget that also includes the balance weights. So what you want to do is have about half the maximum capacity, including the balance weight, when you are imaging. Because if you overload it, you're just going to flex while you're imaging and the stars are going to start to trail and move and what have you. So don't be over-ambitious with the weight that you pile on your tripod. Polar alignment, we talked about that briefly earlier, Ken. Yeah, it is important if you can polar align it. Completely different subject, could go on about it all night. But if the right ascension axis of the mount is pointed very close to the North Celestial Pole, then the guider is going to have to work not much. If it's off it by a degree or so, the guider is going to have to work a lot. So polar alignment is a good plan. I'll talk about balance of the scope in a minute. Periodic error correction, again, Ken's been asking me all the questions before we started. Periodic error correction.
What's your word for you?
It's built into a lot of mounts, and it purports to get rid of the problems that mounts have because the gears aren't perfectly circular, they're slightly eccentric, so the rate they move the actual right ascension head varies across a cycle. The only trouble is when you're auto-guiding, quite often periodic error corrections, which are being input to the mount, are fighting the auto-guiding corrections that's coming in from the star. So switch it off, switch PEC off. It's a great plan, but it doesn't work that well unless you've got a £4,500 mount. So, this is important. Do some trials to see how long you can reliably guide and produce images with nice tight round star images. Depends on your mount. You might be able to do half-hour exposures, you might only be able to do 4 or 5 or 6 minutes. That gives you some idea of where your ambitions lie in terms of fakeness and feasibility. But do some experiments. They used to say your maximum exposure length was the one you could get where you were throwing away 50% of the frames. That's a lot of frames to throw away if you're taking 10-minute exposures or something, but it's probably true. So do some experimentation, find how long you can guide for before you go out to try and get some serious images. Balance, the main point on that is this bit. The balance is adjusted by moving the counterweight such that the right ascension axis is just a touch east heavy. Okay? It just means that the gears are constantly meshing because of the way the weight is. So if you're looking south and you've got the telescope on the right hand side, then the east is the left, so you move the counterweight slightly outwards. And similarly, if the telescope's on the left hand side, the counterweights are on the right, the telescope is now on the east side, so you move the counterweights slightly inwards, just to make sure the east side stays heavy in the northern hemisphere. Alright?
A rough measurement in moving the weight, the counterweight. Is it
Oh, not as much as half an inch. It's just a little bit to make sure.
no specific?
No. Obviously, you want to try and get it as balanced as possible so that it hangs there on the mount.
Yes, exactly.
And that's not just the telescope, but the camera and the cables and everything else. And then you move the mounts whichever direction is necessary, just a centimetre, just to make sure it's slightly east heavy.
Yeah, good.
And that keeps the gears engaged and you don't get any jerky movement.
Brilliant.
Declination, less important. Most set it a little bit tail heavy, back end heavy, and I do too. That seems to work most of the time. Obviously, if the declination's in perfect balance and you've got a little bit of backlash between the gears, then as the thing moves around, it can suddenly flick, and you'll lose a frame. So why not just make it permanently one direction? So most people have it just slightly back-end headed. Manual guiding, waste of time. It used to be done in the old days. I tried it a few times. No. Auto guiding fixes a lot of problems. Yeah, it's required for long exposures. The corrections it makes are tiny. You wouldn't possibly pick them up if you were manually guiding. There was a rule of thumb that you had to have twice the focal length in your guiding telescope to the imaging telescope, so 700 millimeters here, so 350 millimeters here. In fact, things have improved so much now with the quality of the mounts and guide camera software that you can now get a guide camera that you fit into the finder scope, which is tiny focal length, and they still work. I use this setup 700mm with telescopes of about 400mm focal length, 600mm focal length and 1 metre focal length, and it works equally well with all of them, so that's not really important anymore. Some cameras have dedicated off-axis guide ports in them, but again you pay megabucks for them, so if you want to go that way, that's fine. It doesn't have to be expensive. As I said, this is a Little's telescope and it works perfectly well, and I mentioned PhD. There are others. Guide Dog is another one, but PhD I'd recommend. I think it's in version 2 point something now, free, works very well. So this is a parallel setup. So there's your main imaging telescope, and here's your guiding telescope, and here you've got a short focal length one, so it doesn't have to be twice the focal length anymore at all. This is a common way of setting it up, piggybacking it on the top. The only thing you've got to watch for really is what they call flexure. Make sure they're nice and rigid, nicely tightened up together, and they're not floppy little aluminium bars. They're big and chunky ones if you can get them to join things together. And then you won't get flexure between the two scopes, which would obviously be picked up as star trailing in the imaging plane. Bit about the cameras. I can bang on for too long about these. One thing I will mention is if you're going to get heavily into this, modified digital SLRs, there's every kind of modification under the sun, but the most common one, which costs about £150 if you send the camera away that you've got, takes off a filter that sits in front of the sensor, and the job of that filter is to make the camera have a response, something similar to the human eye in terms of colour balance. And to do that, it gets rid of the infrared spectrum and it gets rid of the ultraviolet spectrum because we can't see them. But in the process, it compromises the deep red end of the spectrum where a lot of the lovely red nebulosity is. So you knock that filter element off, and you can either replace it with a new one, which will cost you a bit more than 150 quid, which allows you to see deeper into the red but still cuts out most of the infrared. Or you can just leave it blank and use an infrared cut filter somewhere in your imaging train, so you're not going to get bloated stars from all the infrared energy that's coming off them. That's the cheapest modification you get. Other than that, you can add thousands of pounds worth of cooling and filter wheels and God knows what built into cameras. On the world of filters, you are probably going to need some filters. This says here for monochrome CCDs. Obviously you're going to need red, green and blue, or maybe narrowband hydrogen alpha, oxygen 3, sulfur 2, narrowband filters. But even colour, you're probably going to want some kind of light pollution filter to sit in front of them. That's anywhere you're going to image, unless you're going to go to Dumfries and Galloway and sit in the middle of the dark park, you're going to need some kind of filter in there anyway. Monochrome cameras, but then all cameras are monochrome. Colour cameras just have that wacky Bayer matrix put on the front, which I talked about earlier, so I can blitz through this really. You're going to have to combine red, green and blue, and that's done within the Bayer matrix system in a colour camera to give yourself a colour image. Monochrome cameras themselves do give you slightly better resolution because there's none of that interpolation between little blocks of pixels, but you have to have separate filters with them, as I said. Yeah, Bayer matrix, talked about that. Deep Sky Stacker automates the process of calibrating, aligning, stacking, debayering and creating the colour image, which is what's going on in the background, and hopefully it'll be finished by the time I finish talking. Just a reminder, there's your Bayer matrix, there's your one-shot colour camera to get your picture, there's your monochrome camera, you need red, green and blue, or a whole mix of narrowband filters, so you need 3 times at least the amount of imaging, but you get slightly better resolution. But we're probably following the one-shot colour route there. But the actual sensor themselves, how it works, general theory, think of it as an array of little tiny buckets catching photons, which are droplets of light. Yeah? Just for terminology's sake, the number of buckets in the sensor is the number of pixels, picture elements, pixels. If you've got a block of 1,000, that's a megapixel. Most of the digital SLR cameras are around 16, 18, maybe 20 megapixels, so an awful lot of them. How efficient it is at turning a droplet of light into electrical charge, which is how the bucket stores the information before it's read, is its quantum efficiency, so that's a term you'll have heard. Ain't no sensors out there that are 100%. The best you'll get is about 80% quantum efficiency, and most DSLRs are around 50, something like that. So you'll need at least 2 photons to get 1 electron of charge in the bucket. Yeah? Full buckets can overflow. This is what's called blooming, and you can get some very odd effects if you've got blooming, like spikes of white light that appear in the images. But most cameras, including DSLRs, are pretty good anti-blooming gates in them now, so it's not really likely to be a problem that you'll see anymore. This was what I was talking about earlier, matching sensors to targets. Yeah, well, maybe. You can talk too much about it. Generally, you're going to work with what you've got. Yeah? But for information, the field of view is determined by the size of the sensor, which is pretty big in a digital SLR, compared with the ones we used to get a few years back in dedicated CCD cameras, which is why people use them, and the focal length of the scope. This can cause problems because telescopes are generally designed to look through, not to image with. So they've got lovely bright pictures right in the middle of the field of view, beautifully sharp, but as it moves off to the side, the stars go a little bit out of focus, and also they get dimmer because they're not fully illuminated. So you might have to add something like a field flattener to your optical train, which is another lens you screw into the system, which means that the stars are all sharp right across the field, but they can still be dim at the corners because of this vignetting. So you can get rid of a curved field, but you can't really get rid of vignetting unless you've got a telescope that fully illuminates the whole ship. And that'll be in the blurb when you buy the telescope, if that's going to work. Pixel size matched to focal length. Yeah, no, forget it. You can oversample or you can undersample, but it's not really relevant. As far as we're concerned, people also say you need a bigger telescope rather than a little telescope, because bigger telescopes have more resolution than little telescopes. The fact of the matter is that for long exposures, you'd be really lucky to get 2 arcsecond resolution because of atmospheric motion. So a 66mm telescope will resolve as well as a 5-inch telescope if the sky is only giving you 2 arcsecond resolution. So don't worry about it, use the telescope you've got, is basically what I'm saying. CCD calculator from New Astronomy Press, good piece of software which is also free, download it. It allows you to select any one of about 1,000 telescopes, and if yours isn't there, add your own by giving its aperture and its focal length. You can even add a bar lens or a focal reducer to it if you want. Select your camera, if it's not there, add it, pixel size and the array size in numbers of pixels. Yeah. and that'll give you all sorts of information about what you can see with reference to an old-fashioned piece of 35mm film. And you can also select any one of about 1,000 deep sky objects. In this case it's M33, and it will show you what your telescope and sensor size, so this is the feasibility side of things, will it fit? Yeah? So it's a useful piece of free software, I use it all the time. Right, file formats, very quickly, people can get confused. Just a little bit of theory on bit depth. Your camera saves out a file and it has a bit depth, and the bit depth is the number of colours it can see from fully dark to fully light. The actual sensor can see as much as the depth of the well in the pixels, and most DSLRs are something like 20,000 or 25,000 electron volts. So in theory they could see 25,000 shades of grey. Yeah? But the cameras don't output that because there's a thing called an analog to digital converter inside them that produces the image, and that is usually in a DSLR 12 or 14 bits. All that means is, well, 8 bits is 256 shades of grey, 12 is, what is it?
4096.
Say again?
4096.
4096, 4,100, thank you. 14 is about 16,000.
6384.
And 16 is 65,000.
536.
536.
182.
Sensors people know more than me. The point is, most cameras have got 12 or 14-bit converters in them. Most dedicated deep sky cameras have got 16-bit converters in them. The 16-bit converter will be able to see every shade of grey that is caught on the sensor. But 12 or 14-bit cameras can't, so there's a bit of interpolation that goes on, so you will get some loss of data. So if you are tempted to buy a deep sky camera that has 12-bit output, then probably you're wasting your time. Look for at least 14-bit or above. Yeah? And most DSLRs are 14-bit. I mention that because there's a few cameras coming out these days which have got big CMOS chips in them, and they've only got 12-bit outputs. And although they say they're good for deep sky imaging, they're not really. Okay, capture formats don't capture in JPEG. Yeah, it's a compressed format, so you're losing even more data. You capture in RAW from a DSLR or FITS from a CCD, and I mentioned that earlier, lossless formats. And whatever you save out, I save them in TIFF files, which are another lossless format, to put them into Photoshop or what have you. Digital Negative Converter, DNG, another free piece of software from Adobe. They do give some good stuff away. Sometimes the stacking software, like Deep Sky Stacker, doesn't recognise the RAW file of some cameras. DNG Converter will convert it to a RAW file it will see. So it's useful. If you get some wacky effects in Deep Sky Stacker, just get that software. Right. Camera noise, big point. This is why we do the calibration. Two types of noise: system noise, which is thermal. Mentioned heat, sensor picks up heat as a form of light, which it is. And the other camera noise is when you actually read the picture off the chip. That generates some electricity, generates some more thermal noise. That tends to be referred to as bias noise, which is the reading noise. Nothing to do with anything that the sensor's seen, it's just the effect of reading it. Defects, hot pixels and cold pixels, mention those, and you can get dead lines, pixels and all sorts of things. Vignetting, which we've talked about, comes from the telescope. Dust on the sensor, which will be very obvious, or on the optical window in front of the sensor, or even the back of the focal reducing lens. Dust that's on the objective is going to be so out of focus you won't see it, it's not relevant. So we deal with it with these. Cooling, if you can. With a normal DSLR you can't really cool the camera, but on a nice cold winter night you can do things to help, like leave 30 seconds to a minute between exposures, so that the electronics of the camera has a chance to cool down a little bit before you take the next one. Yeah? That can help limit the noise a little bit. It's not going to be as effective as cooling the sensor, but that's a dedicated camera where you're cooling the sensor anyway. Dark frames, bias and flats I'll explain in a little bit more detail in a minute. And these are the calibration frames that we were talking about in deep sky stacking. Shot noise, this is why we take lots and lots and lots of pictures. If you think of something like M31, Andromeda Galaxy, nice bright galaxy, but it's got dark dust lanes in it. You want to try and resolve them. Think of the number of photons of light that are coming through the system to the sensor from those dark lane areas. In a 4-minute exposure, you may get a very low flux of photons, and they're likely to arrive in random places within the dark lane area. Yeah? And when you take your next one, you're still going to get a low flux, and they're likely to arrive in slightly different places. So each individual picture is going to have a speckled effect in the dark area. When you take lots of pictures, you can average that speckled effect out as if you had one exposure with the light arriving evenly at the same time. This is why we take lots of pictures. In daytime images, completely irrelevant because there's such a bright flux of light coming onto the sensor. But for dark, faint images where you're taking long time exposures, it becomes relevant. So that's shot noise, and we stack, average together multiple images. Inverse square law just means law of diminishing marginal returns. You can't keep adding pictures and get a better result. 9 frames gives you a third of the noise of 1. 49 frames gives you a seventh of the noise of 1. You can't just keep going because the amount of extra cleanness in the picture you're going to get is minimal. So I mean, with quite bright objects you can get away with maybe 9 images. With really dim objects you want to get maybe 20-25 images if you can. The general rule is take as many lights as possible in the time you've got available, but obviously there's no point in trying to get 150 of them because you'll be there all week. A library of matching dark frames, well, yeah, if you can, that's a good idea. As I said, I'll talk about darks a little bit more in a second. And flats, if you have significant vignetting, if that is the case, you probably do want to add flats. Or if you know you've got lots of dust on your sensor and things and you can't get in to clean it, then you want to add flats. So others will disagree because they'll say you've got to add bias frames, you've got to add dark flat frames, and the experts will talk about it for weeks. But generally you can get away with darks. Sometimes you need to add flats. Right, dark frames, what are they? Your light frames are calibrated to remove noise from the sensor and the optics chain. Yeah? So dark frames are taken with exactly the same scope and camera covered, so you put the lens cap on, and the sensor ideally at the same temperature as the light frames. So ideally you want to take a dark frame and then take the lens cap off and take a light frame, and then put the lens cap on and take a dark frame. In fact, that's going to cut horribly into the amount of time you've got available. So what a lot of people do is say, it's -5 tonight, it's a cold night, I'm going to take a library of dark frames at -5 and keep them on storage somewhere. And do the same at +5 if you can. Obviously, if you've got a temperature control camera, that's not a problem if you've got a dedicated temperature control camera. But for a DSLR, take the time to build up a library of dark frames at different temperatures, and then match them as best you can to the light frames for any given night. It's quite easy to take a library of dark frames. You know, you just go out there and say, I want 7-minute exposure, so put the lens cap on, take a 7-minute exposure, and then do it again at a different temperature on a different night. So you've got a library of them, yeah? The exposure length should be the same as your imaging frames. Take at least 10 or plus. I said I've got 20 in there for the same averaging reasons that we talked about earlier. And you can stack them together to make a master dark. That's what Deep Sky Stacker is doing in the background. And the dark frame is subtracted from the light frame to get rid of that noise. And it reduces noise, gets rid of hot pixels, it gets rid of all the thermal stuff that we were talking about. Bias noise is included in the dark frame. That's the noise when you read the sensor. That's why I don't think you need separate bias frames, but other people disagree. That's a typical dark frame for a long exposure off a digital SLR. A whole mass of hot pixels, Cold pixels you can't see because they're just showing as black. Dead lines, yeah, in there. Looks pretty horrid. That's not a bad dark frame actually for a digital SLR, because when you're taking normal daytime pictures, these are irrelevant. Flat frames, these are imperfections like dust and vignetting, as I said. A lot of people take these by pointing the telescope at a uniformly illuminated surface. This would be lovely, yeah? And taking an exposure that gives you a sort of mid-grey picture. Not fully saturated, not fully black, and it'll show you if you've got dark corners to the picture. So that's vignetting. It'll also capture all the dust that's on the sensor or in the optics. And they're applied by dividing it into the light frames. Don't need to worry too much about it. Deep Sky Stature does it for you. You just add it to the list and let it go. That's a typical flat frame. This is dust on the sensor. These circles up here, you can see, are dust on the optical window, which is slightly out of focus. You can see it's brighter in the middle, slightly darker in the corners, which is sort of vignetting. It's kind of a mid-grey picture. So how does it work? Individual frame of M31. You can just about see some of the dust grains here, can you? Don't know if they're showing up very well.
Yeah.
Let's take away, subtract the dark. A lot of stars are gone. They weren't stars, they were hot pixels. Yeah? Let's divide away the flat frame. The dust has gone and it's now evenly illuminated across. That is a calibrated single frame. Now all we've got to do is stack about 20 of those and we'll have an image we can start working with. Yeah? This is what the magical software is doing. It's calibrating and stacking them, and I mentioned the inverse square law before. They're automatically aligned, and I mentioned that when I was telling you how to choose the number of stars to align with. There are lots and lots of different methods. That auto-adaptive AHD method is probably the best one, but I put this up just to mention that one of the stacking methods is a median method, and if you happen to have only got, say, 9 frames, and 3 of them have got satellites flying through the middle, you can either throw them away, you can stack with an average method, in which case those frames will be ignored completely, or you can stack with a median method, in which case it says, hang on a minute, that star trail shouldn't be there compared with the reference frame, I'll just get rid of that and use the rest of the data. So a median can be useful if you have that problem come on. Deep Sky Stacker, why do we use it? It works, it's free, it makes recommendations for you, and they generally work. There are alternatives, but you're going to pay a lot of money for them. Minimum of 100 quid a go, generally. Maxim DL, all sorts of things. This is what I want to work on next for about 20 minutes or so before I finish. M45, I want to try and pull out nebulosity from it. And this is a picture I've taken from the data I showed you earlier, where there didn't seem to be very much in the image but a few stars. Okay? So that's what I'm aiming for. So I'll take some questions at the end. But this is back to Deep Sky Stacker, and we'll see it's run through, it has finished, it's produced a final image. There doesn't seem to be very much in the final image other than a few stars. It also has put up a lovely graph down here at the bottom. Because I chose not to calibrate my red, green and blue together, you can see the red, green and blue have got spikes in slightly different places for the sensitivity of the chip. And all the data is pretty much down at the dark end of the picture. There's nothing much up at the bright end of the picture at all. This is called the histogram, which basically is a measure of intensity against darkness to brightness. Deep Sky Stacker does allow you to play around with that a bit. I don't use it much, but I'll just take 30 seconds to show you what this bit does. You can choose different shapes to that curve. It's currently set for logarithmic, but you can click on those and change the shape of that curve. If I just now ask it to shift my red, green and blue data a little bit over on the curve, what I'm asking it to do is align the red, green and blue roughly, and brighten it, and we'll see if we've got any information there at all. Well, you can just about see that some of the nebulosity is starting to appear. Yeah? Sometimes, for very bright images, all you have to do with them is fiddle with these curves. I don't tend to do anything with them. I don't save the picture. There's a save picture to file option here. So I could save that out as a separate picture and work on that if I wanted. It's a little bit stretched already, but I don't tend to bother. It's just to show you that that's an option that's there. So I'm not going to save that. All I'm going to do now is close that, get rid of those, because I know that if I now go and look in my picture file, in my lights, in my M45, right at the top here I've got an auto save TIFF. It's processed it, it's saved it, and there it is. So what I'm going to do, if I can find it, is open with, no, I don't want to go CC18, so what I'll do is I'll just open Photoshop, if I can find it. Photoshop, there you go. This is Photoshop CS2, which is a version you can get free. Ken's already done it. It's a very, very capable piece of software, which is actually about 15 years old, but it runs quite well on more modern systems. Every time it asks me if I'm going to register it, I'm not going to bother. Okay, file, open. Let's find it again. I haven't looked yet. Libraries, pictures, Astro Lights, M45, autosave TIFF, and we'll open. If you're going to work with or produce a 16-bit image, you have to work in a 32-bit computing space. Without getting technical about it, what Deep Sky Stacker has done is saved that as a 32-bit image. Now, unless I've got a 64-bit computer, I can't do anything to it. So the first thing I'm going to do is change its mode to 16 bits per channel. Now I can work with it. And I'm not going to change its exposure or its contrast. I'm just going to use it as is. So now that's my basic picture. That's what Deep Sky Stacker has saved out for me. I've got a black line down the side. I don't want that in there. That's because some of the frames weren't perfectly aligned. So it's aligned them all with the master frame, but some of them had a bit to one side and what have you. So I'm just going to use the crop tool, which is this one up here, and I'm just going to get rid of most of the stuff that I'm not interested in there. Yep. So now that's what I'm working with. Now what I want to show you in Photoshop, and you can do this with most of the imaging process type softwares, is how to stretch up the dark stuff. And we're going to do that by playing with levels and with curves. And the other thing that this software has is it allows you to work in multiple layers, so you've got versions of the pictures floating one on top of the other. I want to show you how you can sharpen certain areas of the picture by using the layers functions. So if we look at levels and curves and layers, you've seen a lot of what you need to see in Photoshop. I could spend a week talking about just Photoshop. It's an incredibly capable piece of software. But the first thing that we really need to look at is levels. So we've got image adjustments, levels, Control plus L, I can use that if I want to in the future. Pulls up this little boy here, which shows the histogram, again, intensity of light versus dark side to light side. Doesn't show a difference between red, green and blue there, so that's not necessarily terribly useful. So I want to align the red, green and blue data. So up here in the window, there's a little histogram window. If you can't find it in your version of Photoshop, there's a window up here and you can slide down and select all sorts of stuff. You want histogram showing, so there it is. And I want all channels view. And now I've got red, green and blue, and they're almost aligned but they're not quite aligned, and I can play with that later. But what I want to do is play with the levels to get rid of the dark space there which has got no information in it, and to brighten up the light space. So the first thing I'll do is image adjustment levels, and I'll just slide the black point slider along until it gets rid of almost everything to the left of where the data actually is, and I'll slide the midpoint over until we get towards where the peak starts to rise. And you can already see, before I've done anything else, that the background data is starting to appear. So I'll just go OK to that. You'll see that that shifted the red, green and blue all out of balance. So I can control levels again, each individual channel, red, green and blue. In this case, let's look at the green, move the dark point over to just about there. The blue point, again, do the same thing, red, green and blue. And the red, yeah. Okay. Now the thing to note there is the colours are now roughly balanced, red, green and blue to each other. And if you look at the image, where most of the stars are blue, and we know that Pleiades are mostly blue, if I just blow that up a little bit, let's go fit on screen, makes it a bit bigger. You see that star in the middle there? Is a red one. It's starting to pick out the different colours in the stars when the colours are balanced and properly aligned. Okay? The next thing that I want to do is try and drag up the dark areas of the picture, which we do with the curves function. So image, adjust, curves. Well, that's useful. Off screen. There you go. This is kind of like a version of the histogram with the dark areas and the bright areas. If I play with this line, I can drop a point on it, like there, and then I can drag that point up to brighten the dark areas. Yeah? At the same time, I've actually brought any of the stars here into saturation. I've brought them up to fully bright. So I don't maybe want to drag it up quite that high. So I'll drag it down a little bit like that and say OK. And that's changed the levels again. So you can see it becomes an iterative process. I'll just go back to levels. I'll go back to red. And let's just get rid of it. A little bit of dark there. Green. Same again to about there. Blue. And the colours have just about restored themselves again. They're properly in line. And you can see quite a bit of nebulosity. And I might just try one more curves, but I think I'm nearly there. Just generally brighten it up a little bit, maybe. Yeah. And now you can see the stars, you can see a lot of background stars, you can see colour in the stars, and you can see the nebulosity. So that's levels and that's curves. So the one thing left is...
one?
Well, yeah, I mean, as I said, we're running out of time, but the one thing left that I want to do...
And battery, so...
Okay, is layers. What I want to do is see if I can sharpen bits of the image. Now there are filters in Photoshop which have got all sorts of things sharpening. But if you try and sharpen the whole picture, including the stars, you get some fairly funny effects. So what you want to do is selectively sharpen certain areas. So I just want to show you how to make a selection. This little tool up here is called a lasso tool, which would allow me to lasso certain areas. Yeah, I'll get rid of that one. So what I want to do is just select this area here. Yeah. Now if I were to make big changes to that selected area, you would see the effect at the edges. Yeah. So I don't want to do that. I want to feather the effect into the background. So there is selection, modify, feather. There, yeah, better. And because this is a digital SLR picture with thousands of pixels in it, I can use quite a high pixel value. It's got 30 set. I'll leave it at 30. You could go up to maybe 50. And all that does is kind of soften the effect towards the edges of the selection. Right? So what I'm going to do now is copy that into a new layer on top of the picture. So I'll just go copy, yeah, and layer, new layer, yeah, via copy. And it doesn't look like I've done anything. But if you look down here, that's the background picture and a new layer has been added. If I switch off, turn off the eye in the background picture, you can see there's a new layer which has just got that little teensy bit in it. Yeah? So what I'm going to do, you can blend the layers into the main picture in a variety of ways, and this pull down menu gives you all the different ways you can blend them together. So I'm not going to go through those, but the one that I need here is an overlay mode. But what I want to do to that selection, which I've selected and is active because it's dark blue here, is put a filter on it. And the filter I'm going to put on it is hidden away under the other menu. This is the stuff they don't tell you. It's the high pass filter. Put that on it, and generally you want a value of around 15 pixels, roughly speaking. You can vary it, but around 15 pixels. Now that's done something horrible to the picture. Yeah? This is where you blend it back into the layer. And the mode you want is overlay. Now if you didn't think that made any difference, I'm just going to switch it on and off.
Oh, yes.
Yeah?
Yes.
So you can selectively do that to more or less all the nebulosity in the picture. Yeah? And without banging on about all the different things you can do, those little selected areas, you can sharpen them, you can blur them, you can change the contrast by moving individual curves functions or individual levels functions. There's endless things you can do to the small selected area, as long as you put them as a layer on top, such that you can blend them back into the picture afterwards.
What does a high pass filter do?
It's a very good question, and I honestly couldn't tell you specifically what it does.
Because I look at it and I wonder, did this go off and do something else?
It's part of a process called unsharp masking.
It's just there is an unsharp mask.
There is an unsharp mask, but that does the whole process. In unsharp masking, what you do is you blur the picture with a Gaussian blur filter, and then you reapply sharpening back to it with a high pass filter. So you do two processes. So you end up with a picture that is slightly sharper, but the colour saturation has been spread out by the Gaussian blur process at the beginning.
This is how David Millen did all his smart stuff, was unsharp masking the hard way.
Well, unsharp masking the hard way is to do it in two processes. To do your selection, to then Gaussian blur it. Oh, right.
No, I mean,
I see the old-fashioned.
the hard way, yes.
Yeah.
That's what it is.
I think the high pass effectively emphasises edges.
I think you're probably
Yeah.
right.
Yeah,
I couldn't give you how it does it mathematically,
It's
but
used as an image process.
it's quite an abrupt sharpening method.
Yeah.
But it's quite effective, as you can see.
Yeah.
So really, I've spent a long time, an hour and a quarter talking here. I've shown you how Deep Sky Stacker works. I've shown you the theory that you need with some of the terminology you need and why we do these various things. And I've shown you basic processing in Photoshop. In the time available, that's really about all that I can do. But I'll gladly answer any questions as best I can, if you have any.
Right. Thank you very much. So any urgent questions?
Just how long did it take you to learn the whole thing?
Well, no, it's a good question. The one thing that I would
How
say
many
is
years do you fiddle with a piece of software?
I have found people are very happy to discuss their techniques, and there are all sorts of tutorials and things on the internet, but hands-on playing with Photoshop and hands-on playing with Deep Sky Stacker is pretty essential. And I've been lucky enough to go to a couple of workshops where people have done things like this and shown me little tricks and tips about how it works. So play with it. If you want to know, generally it's probably taken me about 10 years.
Tony, do you have a question?
Yeah, so just a quick one. You've got to this stage and you're happy with what you've got, presumably.
Yeah.
Is it just a simple matter of file, save, and
Yes.
save as?
Yeah, you can file, if you just hit save, then it'll just save on the original file that you loaded into it and change it forever. So it's sensible to put it as save as, and then drop it wherever you want. You see, it was going to save it as autosave TIFF, which was the original file I loaded, so you just change the name and call it whatever you
I
like.
used to stick an X in.
Yeah.
I'm talking about hobby photos.
But save it as what you like. And then the format, I tend to save my final images in TIFF, and then I want to have an image I can stick on the internet. TIFF files, well, this one is 52 megabytes, which is a lot. So I would, if I wanted to save that as a JPEG version to put on the internet, first thing I've got to do is to change it to 8-bit instead of 16-bit. And that drops it to 26.2 megabytes, so that's halved it in size immediately. And then I can go File, Save As, and I can call it Auto Save TIFF for the sake of argument. I'm not going to change that, but I'm going to change the format to JPEG. Yeah. I've got layers in there, so it doesn't like it because I've got layers in there. So tell you what I'll do, I'll just flatten the image.
JPEG gets rid of the layers though.
Yeah,
Does it?
it can do, but it doesn't like it. But if you flatten the image, if you look on that part of the screen there, the layers, if I flatten the image, it gets rid of it. So it's gone down to a single layer. And now I can save that as a JPEG, and it'll be whatever size I want it to be, really. JPEG, save. And it says, it thinks about it, and says, well, maximum quality, which is 12, is going to be, think about it and give me a figure. It's probably something like 5
Is that not
5 megs. Usually comes up with a figure just here. Who's thinking about it, that's for sure. But you can change the quality, and it'll give you a lower value. I'm not entirely sure why that's not giving me.
I can't read it. Does that not say something in the size box?
Yeah, where? Sorry.
The very bottom.
No, that's actually probably the size there. It gives you an idea if you are sending it over a modem at 56.6 kilobits per second, how long it's going to take.
Ancient software.
But it usually actually gives you a file size. I mean, it's saying 9 megabits. And if I go down, see if it varies. Yeah, 1.2 megabits now. And I'll go down in quality, and it's half a megabyte. You know, usually that appears in a little box there. But I may be thinking about Photoshop CC instead of CS2. But obviously, you can select the quality of the final image to what you want, save it out, and then post it wherever you want.
So if you overcompress on a star picture, you get these hideous artifacts during the stars.
Yeah, yes, you don't want to overcompress.
It's utterly dreadful.
I generally,
What I've seen.
Storage is cheap.
it is cheap, yeah. I generally keep it at the high end of the quality for a JPEG, because it's not generally that big. 5-6 megabytes.
Ed, you got
I was looking at trying to get a version of Photoshop, and there's one called Elements.
Yes,
If you
Elements
see it,
does work. You have to make sure, if you've got a version of Elements, that it will work with 16-bit images.
That's the problem.
Because
Because some of
CS2 work with 16.
16, yes, yes. It won't work with 32-bit, but it'll work with 16-bit images. Some of the Photoshop elements, they're designed to work with JPEG pictures that people usually take off the camera. And they can do good things, but it'll only work with 8-bit pictures, 256 shades. And if you try dragging up deep, dim data with only 256 shades, you get horrible posterized effects around the edge of it. It just doesn't work. So Elements is not really designed for this kind of work. I think there's one called, is it Paint Shop Pro?
Paint Shop Pro.
That's another layers-based program, so you can do this, put layers one on top of the
It's
other.
less complicated than Photoshop, that's what I used.
Yeah, it does work well, and it will work with 16-bit pictures as well. So you can use that. Elements will work if you've got very bright images, but you can't really drag up the faint data from it with
It's
Elements.
just confusing when you look on eBay or looking for versions of Photoshop.
Yes.
Comes up with hundreds,
Well, you want to search for Photoshop CS2 free, and you'll find websites which tell you how to go. You have to go to Adobe and join the Adobe community, which is just no more than giving them an email account. Yeah. Well, you just give them an email account. You join the Adobe community, and then as a member of the Adobe community, you can download a free version of CS2. Ken's done it.
Yeah, what's good.
It's a lot better than Elements.
Well, thanks
Lot
very much.
better.
No, because I've been on the
Sorry,
sorry.
Ken.
No, it's all right.
All right, sorry.
I've been on that route, but you've explained things tonight that I'll try or develop what I've been trying to do.
Yeah.
See, that's been brilliant from my point.
It's been illuminating.
Well, I hope it's been useful. I hope it's not been too boring for everybody, but I hope it's been useful.
Yeah, that's exactly. I was getting to a point where I couldn't get any further because I was doing certain things you explained what I shouldn't be doing, what I have been doing.
Okay.
So I'm off to try. I think
I think it's getting those first steps of actually knowing what the kind of process is to get
I've got these, but this is great. Having it's the furthest I've got stuck at a certain point. Fantastic.
So, any more questions? No? Well, I think we'll say thank you again to Alan for